Alright, in this video we're going to talk about derivatives. In order to find the derivative, we'll first start with the limit definition. After using the limit definition, we'll learn that there's actually shortcut techniques for finding the derivative, but for now, we got to use the limit definition. So the limit definition says the derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So the first thing I'm going to do, I have f of x right here. So I have this piece. And obviously we'll have h. So I just need to find f of x plus h. This means everywhere that I see an x in my original f of x, I'm going to replace it with x plus h. Then using some algebra, I'll end up with f of x plus h. Alright, so now I can organize this. Limit as h goes towards 0. Have to put my f of x plus h first. And then minus f of x. All over h. Let's go ahead and simplify. I canceled my like terms. Notice that everything that I have remaining in the numerator has an h. If let's say my numerator, there was some expression that didn't have an h. It just had an x term. That means, or would indicate to me, that I made a mistake somewhere when I was simplifying it. Maybe I made a negative mistake. Maybe I forgot to distribute the negative to all pieces. Or maybe the negative mistake could have came from here. So again, if you end up in your numerator, so all these terms should have an h. If any of them didn't have an h, then yes, we made a mistake. Somewhere in our algebra, we should go back and find it, because the goal here would then be to factor out the h they have in common in the numerator. Cancel with the h in the denominator. Then from here, we can apply direct substitution. And we know direct substitution means just replace the h with 0. Why don't we replace the x with 0? Because this is the limit as h approaches 0. So we'll replace the h with 0. And we'll end up with our final answer being 8x minus 5. Now eventually we'll learn shortcut techniques like I call the power rule. And the power rule for derivatives will also end up with 8x minus 5. Alright, so hopefully this was a nice video showing you how to use the limit definition to find derivatives.